I do camera and cinematography work, and I often use gimbals, which require my lenses to be equipped with gears for proper focusing. Many of my lenses are vintage photo lenses, however, so I create my own using 3D printing. Today, I'm going to take you through my process for doing that using Blender's geometry nodes. Okay, so this video is going to be a bit different from the others I've done. I've done two videos, as the instructions are a bit more specific in this one. In this one, I'm just speaking live over what I'm doing as I create the node tree which generates the lens gears. If you're not interested in learning how to do this and just want to print some lens gears, then I've included a download link in the description for this Blender file. You can download it and skip to this timecode in the video, and I go over how to use it to generate your gears. Okay, so the first thing we're going to do is we're going to go over to this page. We're going to look at these lens gears STLs by a guy called Jamis, and this is going to be the basis for the geometry of the teeth that we're going to use. I used these years ago when I first started printing lens gears, but today we're going to adapt his work into something that I can use to generate custom lens gears using Blender. Now, of course, you could just use these gears. He has, if you download it, you can see that there is, just so many increments that you don't need to model a specific one. You can just find the one that's closest to your lens diameter and print it off if you want, but that's no fun. So let's give it a go. Okay. Press 7 to go to a top-down view. Now, we're just going to import one of the STLs. It doesn't matter which one, just a random one. And what we're going to do is we're going to grab the tooth and use it. Okay, so go into wireframe, press B and select everything with left click. And we're going to P to separate selection. And now you can hide this, we don't need it. And I'm going to scale the Z-axis, 0, and then search for merge by distance. Then go into object mode with tab and search for convert to curve. And now we have a curve outlining our tooth. Put origin to center of mass. There we have it. We're just going to put this off to the side. We shouldn't need to look at that again. Okay, create a new object. It doesn't matter what the object is, because we are going to go now into the geometry nodes and add new. I'm going to disconnect, hold Control and right click to cut through things. Let's move this over here. I'm going to turn on snapping because it helps for organization. Now we're going to start with the mathematics used to calculate the teeth. So we're going to add a value, and I want to rename this to, we're going to call this space between teeth. And all this is, well, it literally is the space between each tooth, and that's going to be a constant. It's something that I've already worked out. It's basically using the number of teeth on the models that we downloaded on Jamis's models and dividing by the circumference divided by the number of teeth, and that's the distance as a constant between the teeth, and that is 2.5272. So we're going to put 2.5272. Okay, then we're going to add a math node, and we're going to duplicate it. We're going to duplicate it, Shift D to duplicate, and we want a multiply, we want a divide, and a divide. Now we're going to connect this to here, this to here, and this to here. Now we're going to grab an input node from here and pop that in the first one. And what this is going to be is the number of teeth, that value. So we're going to go into group, value, number of teeth, and that will allow us to input the number of teeth into the modifier later on. So the default should be 90. We're going to make this a integer. Default is 90. We're going to put this at 90. It doesn't matter how many. The number of teeth is going to set how large your gear is. And the min would obviously need to be, let's make it like 10 because it's not going to work at that low anyway, and the max can be anything. There is no max, so I'll just leave that as this ridiculously high number. And I'm just going to, if you hold shift and then use the right click to make a cut through the line, you'll be able to route the line to make it a bit neater. Okay, so this value here is going to be 2, and this value here is going to be pi. So that's going to be 3.14159. Okay. And what this is doing is multiplying the space by the number of teeth to get the circumference, and then dividing by 2, and then dividing by pi, and that equals the radius. That's just some basic circle math for you. So what we have now is the radius. So what we're going to do here is we're going to select that, Control J, just to group them together, and we're going to go into Node, and we're going to label this Tooth Math. Now we're going to come up here, and we're going to create the teeth. So we're going to curve circle. This just generates a circle of radius, whatever you set, and the resolution, whatever you set. You want to put the resolution up to something high, 256. Otherwise, it's actually going to be a, well, for instance, if you put 5, and if I put this in geometry, you can see that it just creates a hexagon, and if you increase the number, you know, now it's an octagon, but we want it something high so it appears to be a circle. It's close enough. And then we're going to plug the radius into here. Like so. Now curve 2 points. What this does is it generates a lot of points around the curve rather than have an actual curve itself, and the count needs to be the number of teeth. So we're going to put this here, like that. Right. Now we're going to add instance on points there. So you're going to move all of these up a bit, make a bit more space. And our instance, we need an object info, and we need to put in our, it's this one. I should have renamed this really, so let's do that now. Let's call this tooth profile. Tooth profile, and the geometry goes into instance. And you see we're starting to get what we want here. But it's not quite right, is it? They're pointing the wrong direction, and that's why we used curve to points rather than just plug, because you can just plug curve directly in there and change the resolution. And it's similar, but we need this, we need rotation. So I'm going to move this over here, move this up here, out of the way, move this over here, and we need separate X, Y, Z, and that's going to take the rotation coordinates and separate them into their X, Y, and Z components. We want a combine X, Y, Z, nope, we need a combine x, y, z, and we're going to put z into z, because we only want the z rotation, we don't want the rotation of x and y, so we're leaving those alone, and that goes in rotation. And there you go. Right, and you can see that as we increase the number of teeth, the radius will increase to match, and yeah, that's pretty much perfect, isn't it? Now I'm just going to bring in our original gear just to check that everything's lining up. So if we increase the number of teeth here until we get to roughly the same spot, yeah. Now it looks like my value is slightly off. I may have used a I know what this is. So we go to space between teeth, and we're just going to very slightly alter it, because clearly it was wrong. 2.5973, 2.5, 2.51, 2.505, 2.55, 2.51, 2.5. Yeah, I think that's as good as we're going to get. Clearly this model has been updated. I actually used an older model that I had been using to calculate this value. Just going to minimize this and tidy up a little. Okay, now we need to realize instances. All that does is it makes it an actual mesh instead of a load of sort of children or clones. Then you need to fill curve here and make n-gons. It doesn't really matter which you use, but I prefer n-gons. As you can see, it's not quite right, so I'm just going to 2.501, 5003. I'm splitting hairs here. My printer isn't capable of going this precise anyway, so it doesn't matter. I'm going to group all this together. Oops. And we're going to call it teeth instancing. There we go. So now what we need to do is we need to add a circle. We're going to make this a mesh circle. And we're going to use this as the radius to start with. Move this over here. Add a mesh boolean. This merges two meshes together. If you set to union, put those together, and change this to 256, 512. Change the fill type to n-gon, and you can see that it's merged, but our circle is too large, so we need to add a math node here and subtract, and just increase this value until it is just the right amount. So 0.8. That looks good. We will go with that. Just going to move this down here. Move this down here. I'm going to group those together with Control J and call this main circle. Right, we're getting there. If we go to solid, you can see that, hide this, you can see that this is the shape that we've created. And we can increase and decrease the number of teeth. Like so. And that works quite well. So now we need to add some thickness to this. So keep this here, move this over here. We're going to extrude the mesh, and as you can see here, this extrudes it, and we are going to grab one of our inputs and put it here. Let's rename this to width. Call it width. That's a float. The default, let's make it 20, as in 20 millimeters. That's quite thick. You'll probably want 10 or something when you actually create your gear. We need to change the extrusion type to, yes, it's faces, and uncheck individual. Make it so the whole face is extruded. Okay, let's tidy up this, like so. Now the problem, you can see, is that the bottom face now is not filled, so we need to join geometry here, and we need to grab the original face that we extruded and add it back in, like that. And then we need to do a merge by distance, because those vertices aren't actually joined to each other. Like so. Now another thing I want to do is I want to add a transform node, because right now when we change the width it goes up and down, and I kind of want it to extrude from the middle. So I'm going to use this. I'm going to add in a combine XYZ, pop that into transform. I'm going to grab this, I'm going to put this into Z, and this moves it up exactly the scale that we want, but we need to add a math node. We need to change that to multiply, and the value is minus 0.5. So now, if we increase the width to say 10, it scales from the center, which I think is slightly better. So that's what we're going to go with. Move this over here. Now we're going to group all of these together, Control J, go into node, and we're going to call this extrusion. Okay, so next we want to chamfer the edges of the gears to make it a better print, to make it slightly more appealing as an object, I suppose, but mostly it's to prevent the bulge that happens at the base of prints from interfering with the gears. So we're going to create a curved circle, radius to be the radius here. So just going to route this down here. I'm going to add another mesh boolean. Actually, for now, I'm just going to join geometry, just so we can see what we're doing here. And you can see it's just added a line here. Now what we want is curve to mesh. Add that in here, and we're going to quadrilateral. We want a quadrilateral, which is a type of curve, and it's going to use it as a profile, like so. So you see this. We've created this kind of square ring, I guess. Change this to 256. Now shade smooth. By default, curves are shade smooth, but we want to shade it flat. So we somewhat unintuitively we make a set shade smooth node and then uncheck it, and now we have a flat shape. So now what we're going to do is move this here, create a transform node, pop that there. We're going to rotate in Z, I think, change that to 45. Let's add a math node, and what we're going to do is we're just going to increase the size slightly. We want to increase this value until it's about there. Yep. Because we want it to intersect it's difficult to explain. You'll probably see, you'll understand when we do it, when we make the bevel. So let's pop this here, tidy up a little. So we want to create transform. Pop that here. Shift D, move it downwards because we want two of these, one for the bottom and one for the top. Pop that down there. We want a combine X, Y, Z. Put that into translation, and what we're trying to do is we're moving it. Actually, I'll just pop that up here for now. We want one to be up here to cut the top, and we want one to be down here to cut the bottom. So this is going to be equal to our width divided by 2 and inverted, right? So our width is here. We're going to grab that and we're going to put it into Z. Let's just move this down here and here. Add a math node, and we're going to divide, rather, by -2. And now it appears down here. And we're going to do the same for this one, but we're going to just divide by +2 instead. So we're going to grab these. Let's move it down here, move this down here, grab these and duplicate over here, add that to translation, make this +2, and we should find that, yes, there it is. Let's move this here, move this here, move this here. I'm going to move this down here. I'm going to add a mesh boolean here, and we want to leave this as difference today, so we're going to add this here instead. I'm going to cut that, so we're going to cut that, so we're going to put this in here. Voila! We have beveled the edges. So now we're going to group these, Control J, we're going to label this bevel object. We are nearly there, so the last thing we need to do is cut the hole where the lens goes into. So mesh circle to start with, so change this to the usual 256. Let's just see what we're doing here. So we have that. We want our radius to be based. Actually, our radius is separate, so we're going to grab a new input node, put that in radius. Just going to loop this overhead. Okay. Let's call it lens diameter. Because you're going to measure the diameter, you're not going to measure the radius, so we'll do a diameter and then add math. Go in here, divide by 2 to get the radius instead. So let's say our lens diameter is 60 mil, just for the sake of argument. Pop that there. Fill type n-gons. We want to extrude this in the same way as we did before. So let's just grab this whole set of nodes and move it up here. Delete the group. We'll use this as our base. So let's see. Put that in there. Put that in here. What do we get? Let's grab. This is the width, so let's grab that. Pop that in here. Right. Let's move this over here. We also need this to be in the extrude scale. So now, as we change the width, yeah, that happens. And we will also want a math node. Just add a bit to it. Is that there? So like that happens. Okay, and just so we see what we're doing, I'm going to add a join geometry node. Add that here. Okay, so you can see that we've inserted this as we increase the width of the lens, the gear to say 30. We see we're having a problem here. I have to sort that out. But it should do that. Join geometry, add that back in. Yes, so that's what it should be. Move this up here. Move this here. Right, so delete this join geometry, and we want a mesh boolean. Pop that in there. Grab this, put that there. Grab this, pop that there. And now we have a hole that's been cut, and we can change the lens diameter to whatever we want, like so. So say if your lens diameter was 60, that's a pretty unnecessarily beefy lens gear, so you'd want to reduce the number of teeth to say that's too far, to say 80. If you wanted the lens gear to stick out a bit further, which you might do, I find it's useful so that I can make a whole set of lenses that have exactly the same gear width, so that it's easier to change lens but keep the focus exactly where it is. It's handy for that, so you might want to do that. You can. Let's group this together. Control J. I'm going to call this lens diameter. Like so, and that should be it. But I just want to take a look. I just want to take a look at why that little glitch happened earlier. So, okay, let's grab these. Move them over here. And we want another math node here. And we want add and add. So let's make 0 to start with. Because the problem is that this edge is perfectly in line with the face, and that's causing some confusion with the calculations. So let's add just 0.1. I see we're doing the wrong one. Let's add 1. That's too much. 0.1. 0.05. And change this. This probably needs to be minus 0.05. Let's have a look. That's correct. Okay. Let's go back to this, see what happens. It looks like it solved the problem. So let's bring the width down. All looks good to me. Okay. Delete that. We have the node setup now to create custom lens gears. So if we just put the width, 15 is a good one. Assume our lens diameter is maybe 70. To increase the number of teeth to 100. Perhaps 95 is enough. Right. That's that. Now, you might have a strangely shaped lens. For instance, one of my favourite lenses is the Tacumar 50 1.4, and as you can see here, the lens is not shaped in a perfectly circular way. You could put a circular one on there, but what I like to do is create a custom shape in the centre to match this, and it creates the little divots. So if I show you one that I've done in the past, I can import an STL Tacumar 50 1.4. You can see here that it has a customed shape. I could of course create some kind of geometry node setup to generate these, but each lens is different, so this is something you have to model specifically to your lens. You have to measure your lens and model, and then you can create an object which cuts the hole in the gear. So what I'd do in that situation is I would reduce the lens diameter down to, say, something really small to give you lots of space, and then create an object. Say, for instance, well, I have this one, so I can show you. What I originally did with this one was I modelled this shape. I measured the lens with my calipers and I modelled this. So what I would do here is I would move this to here, I would scale it up. This would only need to be 10 or something like that, maybe even less. Then I would reduce the number of gears until I have something that I want, maybe that. Then create a Boolean modifier, make it fast, difference, and then select this. And if you hide this, you can see I have created a lens gear that will fit a Tacumar perfectly, and that's how you would do it. It can be a bit time consuming making this shape, and it's probably a separate video to do that, but I could do it if you want. Just let me know. Right, there you have it. So now I'm just going to delete this. I'm just going to undo what we just did. So I'm just going to export this now as an STL selection only, 3D prints, lens gears, test. I'm going to go into Cura and we're going to see if this has exported correctly. It's possible there's things wrong with the geometry of this which make it difficult to print, so we will see. I actually have this set to PETG because that's the last thing I printed. I'll change this to PLA. Discard changes. So we have our gear. Let's see if it slices. It looks good. Looks like it will print just fine. So now I'm going to create one specifically for a lens, and I'm going to print it, and we're going to attach it and see if it works. Okay, so here is the finished gear. I decided to experiment with this one, as I already have lens gears for all of my lenses that I need, so I made this one out of TPU. I've made all of my previous lens gears out of PLA, so I thought this time I would see how a stretchier filament like TPU would work. I slightly undersized the inner diameter so that the gear could stretch over the lens and have a tighter fit in theory, which it did, but in hindsight I think that PLA is a better material for this, as the rigidity makes it more reliable. Although it does work, as you can see here, I've attached it to one of my spare cameras, and having attached a follow focus, you can see that the gears mesh just fine and it works. If you have trouble getting your gear on the lens, then you can try using a heat gun or a hairdryer to warm it up and make it more elastic. Just a little bit, then as it cools down it will shrink a bit and you get a nice tight fit with your lens. Right, that's it. If you want to see more useful 3D printing, and that's the only kind of 3D printing I really do, then subscribe for more. If you like this video, then I'd really appreciate it if you left a like and or comment. Thanks for watching, and see you next time.